My name is Francisco Madera. I'm coming from Mérida, Mexico, from the Universidad Autónoma de Bogotá. I'm very happy to stay here in the International Symposium of Language and Knowledge Engineering. And I want to talk about the work we've been working so far. Let me share the presentation. Okay, here we are. The title is Towards an Intelligent Person Assistant for Hearing Impaired People, and the work team is formed by Takutsuki Alexander, Jorge Rios, Francisco Madera, and Humberto Perez that is coming from Nayarit, from the CISESA UT3. This work has been focused on the part of the population with hearing impairment who owns a dog and worries about not listening the dog bark, especially when the risky situation is taking place at home. The goal of the work is to develop a device that allows to recognize dog barking and send notification to a mobile device to assist people with hearing disabilities. At the beginning of the work, a survey was conducted with hearing impaired people to know the kind of sound-related situations at home, considering them by risk. After the literature review, no work was found that includes both the hearing impaired people assistant and dog barking detection. Our work utilized more data for training, and the work is used in some related research. The contribution of this work is the design and implementation of a device capable of automatically recognize the dog bark as a tool to assist people with hearing impairment. The system includes a model for dog barking detection that was trained using support vector machine algorithm, a model for capturing audio by using a speaker microphone array, a device for audio processing and classification based on the Raspberry Pi 3 card, and a notification model for sending warning messages to mobile device and executing visual feedback. Ambient intelligence is a concept coined to define an ambient which provides people assistance by means of sensors and processors integrating into everyday objects. Ambient assistant living, AAL, which aims to identify activities to recognize behavior of humans in a specific space in order to provide automatic assistance. Our approach includes a supervised learning algorithm that is an iterative process of training with manually labeled audio data and testing classification results and selected audio sample to reaching the desired precision. Specifically, the support vector machine algorithm was employed, which allows classifying two or several classes adjusting one or several hyperplanes so that the separation between classes have the minimum possible error. The methodology. There are several phases. The first one is the capture analysis of requirements. The problem was defined about the requirements for hearing impaired people to increase security at home. A survey was applied to determine the most frequent and risky situations of hiring impaired people. There were 32 participants that took part of them. The 5 resulting sounds were produced by home appliances, dog barking, produced left behind any door, sink faucet left open, and produces at the main door. In the second phase, a communication interface was proposed to mediate between the user and the device. In the third phase, the implementation, we will describe in future slides about how we integrate the Raspberry Pi RIS speaker, the case to notify hearing impaired people about some bark dogs. Finally, the fourth stage is the testing. The Raspberry Pi 3 is a play computer for building embedded electronic prototypes. The RIS speaker array is a chipset with 4 microphones that allow us to recognize audio and perform various tasks in real time. It recognizes the position of the sound source. It can be connected to the USB port and to receive the power. In the figure below, we can see both devices. The first one is inside the case, and the rest speaker is in the top of the case. Data collection. The database called Mescaline variety database. Mescaline FX API of CV was employed. This database contains the barking of more than 100 dogs storing 8,000 audio files. Additionally, the bars of 3 mixed breed dogs were recorded using the rest speaker microphone in order to have samples obtained from our device. From the database, 70% of the audios were used for training and 30% for testing. Feature extraction. A bar is composed of an audio segment range 0.1 to 0.8 seconds. The segments are used for the machine learning analysis consisting of feature extraction and comparison with a super vector machine training model. It was decided to use by audio analysis to extract audio features. The software provides 34 features grouped into the following categories: zero crossing rate, energy, entropy, spectral, and FCC, chromograms, chromogram deviation. In the smartphone, a notification allows application to inform users of incoming messages, new system events, remainers, without requiring explicit interaction. The notification content and the identification of the best moment for presenting notification are fundamental to develop a successful notification system. One sign-up was chosen after being compared with other tools like Telegram and push-over technologies. There are some aspects to be considered, definitely. I'm going to notify the user. Sending a notification each time that a bark is recognized could be annoying for the user. In that case, a second layer of recognition must be enabled, one that can identify barking behavior linked to the context. For instance, an aggressive barking at the middle of the night could convey more risk than a friendly bark in lunchtime. The implementation. The prototype is a cylinder-shaped case that was designed and was printed in 3D, considering the shape of the reed speaker microphone array and the size of both devices, the Raspberry Pi and the reed speaker. The main idea, the guide in the design was to have physical objects that can be placed in a location close to the dog. This device would be integrated to the Wi-Fi network of the home to notify the user about dog behavior. Not only bar, but also location, time, and other context information will be included to decide identification action. Such idea approaches the Internet of Things vision of future. In this illustration, we can see a dog that is barking, and people, hearing impaired people that is listening, receiving a notification from his mobile device. The machine learning model. Efficiency of the support vector machine was tested with an external database according to the audio recognition. To find the best support vector machine hyperparameter tuning, we employed a grid search CV function of libsvn library for support vector machine using a Python script. Subsequent to the linear, polynomial, radial, and sigmoid kernel functions were tested to obtain the best bar recognition model, which resulted in being a polynomial kernel with cost equals 1, degree equals 5, and gamma 0.01. The percentage of the accuracy was determined, and it was verified that audios could be recognized correctly. Segmented audios had a duration ranging from 0.1 to 1 second. And the receiver operating feature could summarize the performance of a model of different classification thresholds that we can see in the image below. False positives and true positives behave well in our model. Points plotted above the dotted line are considered as a better classification. And we can see most of the points in the top of the graph. The confusion matrix was used to support as a support to determine how much the model confuses the classes with each other. The values in the classes column refer to the actual data, and the values in the predicted rows are the results of the algorithm used to support vector matching. A good result is to have large values in the cells that match the class data with predicted. It can be seen that there is good behavior toward false positive in the table below. Online BART prediction. When a model was deployed in the Raspberry Pi card, the prediction task was performed on the audio stream directly by taking segments of 1 second without overlap. But it was remarked that the prediction was poor. A new proposal was made to process the incoming audio to have a better result. A survey was conducted to evaluate acceptance of the proposed concept with heavily impaired people. The question asked if the color and intensity of the visual feedback, the design, general the notifications sent on the device were adequate. They were very happy. In general, the participants felt satisfied with the prototype. They thought it was appropriate to send notifications to the mobile device. As far as we're concerned, this is the first work that combines parking, recognition, and assistance to hearing impaired people. Our most significant achievement was to fully integrate technologies in a proof of concept for a functional device capable to recognize the barking and notify users by means of colored lights and mobile notification. We examined the performance of our methods in terms of the features, classification, approaches, and applicability. The hearing impaired people participation in the development process has been very helpful. However, their expectation could exceed the technical capabilities that our prototype can deliver. Hearing impaired people comments support that the use of our prototype will help them to increase their safety and confidence at home. As a future work, we plan to design a test scenario that includes real dogs to estimate the generalization for the machine learning model. The request and feedback from users at the core approach is necessary to perform another study with more users in realistic scenarios. Privacy issues will be addressed as an Internet of Things device is in contact with confidential data of users. The design of the prototype will be adjusted to match expectation of hearing impaired people, mainly in size. It is projected to grow the audio database with the non-labeled BARC samples in order to test deep learning methods of sound classification. Incorporating capabilities of the microphone array to determine the direction of the sound source could increase the information provided to hearing impaired people. Thank you very much for listening. Our emails are specified in these last slides.